I want to talk to you a little bit more about power series and what they mean. A lot of times my students have had a little bit of trouble with the alphabet soup nature of it, that there's X's and N's running around and what is a variable and what isn't. Power series to me, well, technically it's an algebraic expression, but it nearly always represents a function, okay? The thing about power series is there are coefficients running around and there are variables running around. So you can think of it as f of x, where x is a variable and can be whatever you want, and the a and the n means something completely different. Each x, you get to plug in an x, just like with f of x equals x squared. You get to plug in whatever x you want. And every time you plug in an x, you're going to get a different series. So for example, here's a series that I could play with, a power series. If I were to plug in 0, I would just get the sum of 6 times 0 to the n power over the square root of n, and that's an infinite series where every term is 0. So I know that f of 0 is 0 in this case. On the other hand, f of 10 is the sum from n equals 1 to infinity of 6 times 10 to the n over the square root of n. Now the thing about this series is when I plug in n equals 1, I get 60 over 1. When I plug in 2, I get 600 over the square root of 2. I get 6,000 over the square root of 3 when I plug in 3. So this sum is actually, the sequence of partial sums is getting really huge. These terms are just getting bigger and bigger. So f of 10, well, the series for f of 10 diverges. F of 10 does not exist. So there's, in my mind, there's this equivalence between the interval of convergence for a power series and the domain of the function when you think of the power series as a function. Those two things are like kind of the same. So here's an example. F of x equals the sum of 6 times x to the n over the square root of n. And I could ask, what is the domain of this function? What is the interval of convergence for this series, this power series? Now, most of the time, the root and ratio tests are going to do most of the work finding the domain for you. And all you have to do is you have to set up this. This is going to be ratio test. You set up this ratio, compute this limit, and then use the results that you find. Those are very powerful tests. So the n plus 1th term is this with n plus 1. So see how I have 6 times x to the n plus 1 on top, and I have radical n plus 1 on bottom. That's just a n plus 1. And I need to divide this by a sub n, and I'm going to use the trick where you multiply by the reciprocal. So we're going to have radical n over 6 times x to the n. Now this is equal to the limit as n goes to infinity of x times radical n over radical n plus 1, okay? Because the 6's cancel, most of the x's cancel except for 1 on top, and I just group these two little dudes together over here. Okay, so this part, so this x has nothing to do with the limb, so it can actually pass outside. And this expression right here, as n goes to infinity, that goes to 1. So this limit is equal to the absolute value of x. What this means is, this limit, if x is 1, this limit will be 1. If I'm thinking about f of 3, this limit is 3. And the ratio test says that if this limit is between -1 and 1, the series converges, okay? And that means if x is between -1 and 1, then f of x, that series converges. And so that means that the interval of convergence, or the domain of f, is one of these 4 intervals, -1 to 1 with round brackets or square brackets, I'm not sure which. And just like in the other examples from this lesson, we actually have to compute f of 1 and f of -1 ourselves and decide if those two series are convergent. That goes a little quickly. When you plug in 1, you just get the sum from 1 to infinity of 6 over radical n, and that's divergent by the p-series test. And that means that f of 1 does not exist, and that means a parenthesis. F of -1 is the sum of 6 times -1 to the n power over radical n, and now that's alternating, which kind of changes everything. This guy is definitely convergent by the alternating series test, and that means that the interval of convergence is -1 to 1.